Hello guys, in this session let's dig a little more deeper into check against source. In this video we learn about binding and unbinding instances, as well as if at all there is a change in the instance name, and also editing the parameters here. So let's create a scenario first, because these problems you will come across when you have edited without generating a device. Say if you have forgotten to generate a device, and in a hurry, if you have just copied a device and you have ended up using it, LVS goes through, it's all fine. But sometimes the protocol of the company will be that you should have all the layouts Excel compliant, or you should have done check against source before you check in your design or before you deliver your design. Okay, so let's create a scenario here. Let me pick up these three transistors here. I'll click M5, MN4, and MN3. I'll say copy these. Okay, you see here, the moment I copy, the instance names have changed here. I'll just select these three and I will delete them. Okay, so now let me first take one by one here. Okay, now first here, now I have copied these devices here. Now they don't have any binding with respect to the schematic over there. So now I will try to run check against source. Connectivity, say check against source. It will give me all the parameters, what all I want to check with respect to the source. By default, I'm just turning on everything. Just click OK. Over here, you see here, it gives me an information saying unbound instances, 3, and ungenerated instances. So what it is trying to convey here, that you should bind these 3 devices, okay, to the respective device in the schematic. And on the other hand, it's also telling us that you have not generated these devices. Something is missing here. You have not placed the correct devices here. But we know that it's just a copy here. Even though it's a similar kind of a device, you have just copied it, but still it is not finding the connecting information between schematic and source, because we are doing CAS, that is check against source over here. So what we'll do here is, let's take device one by one and we will try to fix this. We can do it multiple ways. I just say right click. Okay, let's see bind. Let's see what options do we have. Click, right click. Okay, let's click here. Right click. You see here, bind. Click on bind. Here it will tell me which device I need to bind here. So I5, I know that. You see this is a form which gives you information about binding here. Okay, this gives you the connectivity. This is the layout side and this is the schematic side. Now that I've just copied it straightforward, I know that this is the device which is corresponding to MN5. Am I right? So that then I'll say bind. Now here it is telling me bind the name and the parameter both. Say bind. So this will show me the binding exactly to this device here. Okay, this is one way. Let's see if at all there's another way of doing it. Okay, click here. Now I'll click on this. Right click. Here you go. That's one way. Update, define device correspondence. First thing, I clicked on this, right click on this. That's one way. Second way, right click, update, define device correspondence. I6, this is nothing but my MN4, right? Because when I was copying, you could see that M5, M4, and M3. So I know that this is what it is. So I'll just click, bind, close. This is also bound. Let's see what are my other options. Let me see if at all it's possible to do it here. Right click, check, uncheck, settings, right click. Okay, I guess there are only 2 options here. Let's go with that. Right click, select this guy first, right click, update, define device correspondence, MN3, bind, and OK. Right, so now it says incomplete nets because the connectivity is established now and you are expected to place them as is. Now when you are placing the connectivity over here, right, Now that the connectivity is there, it is giving you incomplete nets error. So earlier it was showing binding and unplaced instances. Now that you have created a binding, the tool has established the XL connectivity here. That's the reason it is giving you incomplete nets. Okay, now let me just take this, guys. I'll say Shift F and I will just align them where they are, and even this guy will vanish. There you go. Okay, now this is one scenario. Now I'll show you another scenario wherein, okay, I will take this guy here, take this, copy, place it over here, and then I just delete these guys. I'll copy this back and place it again. Right. See here, the names are different. Right? When I copied, the names were different. Now, when I run check against source, save, connectivity, check against source, now you will get only name related errors. Earlier, I had placed these devices here. They were unbound. That's the reason you got binding and unbinding errors. Now I copied the devices and I placed back them before connecting to these, because connectivity exists on these nets. Connectivity exists on these devices. So connectivity is, these devices are getting connectivity through these terminals which already has pins. These intermediate nets already have connectivity. That's the reason it is not giving me binding and unbinding related errors. Now it is giving me that instance names are different. Right. So what I'll do, I'll come here, right click on this, update names. It has picked up MN5, the corresponding based on the connectivity what the other nets are having. The tool picked up that this device should be MN5. Let me just select this, right click, let's say update, define device correspondence. Here it is already there. So just leave it. Easier way is, let's see if at all there's another way of updating names. Right click, MN9, let's take this. Update name, I don't think it's here. So it's easier way, you have options, just go here, right click, update names, right click and update your name. Then this is done. Okay, save it. Now there's another scenario here wherein I will just change the dimension of this device. Okay, so here let me make this as say 300 nanometer. Now I'm not changing all the other parameter settings here, like all of these. So in earlier video we have seen, if at all these parameters, device parameters, are different from schematic and layout, what you should be doing, we have seen in the previous video. In here what I'm trying to show you is the length and width. If at all the length and width are different, then what you have to do. Assume by mistake you ended up copying it, or there is some update in the schematic and your layout update has not been done. In cases like that, you will get lots of parameter errors. Now, all these things you can very well, some of these things, in fact, some of these things can be caught while you're running your LVS. But the connectivity related information or instance binding related information, naming related information, all of that you will not be able to catch it in your physical verification. These are specific to XL compliancy. So now I have edited this guy here, parameters. What I'll do, I'll just save this, connectivity, check against source. Here, just leave it default or select everything, click OK. Now you see that the parameter says it's different. If you observe here, drop down, expected, that is the one in the schematic. In the schematic, I have the device width to be 350 nanometer, whereas in the layout, I have got 300, which means what? I should update my layout over here. Okay. Here, let me click here. Let me see if I can update. No, this particular option doesn't give you here. So let me just go to this GALIF. This icon is called as GALIF. Right click, update layout parameter. Automatically it updates to what is there in the schematic. So likewise, when you are generating dummies and all of those stuff, you will get lots of things. So in here we have focused about parameters, instance name, and connectivity of this. That is binding of instances. Okay, that's about your usage of the feature check against source. Same thing comes into picture when you dealing with Excel connectivity also. Okay, it will again open up the check against source and all. If at all you are dealing with, if at all you specifically want to check on Excel connectivity, you can use the Excel feature. Else check against source will take care of all the other things. So you can utilize these features when you have to have a Excel, completely Excel compliant layout and schematic. Not every company demands for this, but some of the companies, they expect you to have a layout which is Excel compliant, even the instance name, the binding, and the parameter matching, all of these things. Some of the companies call it as logical compliance check, LCC checks. Okay, so that is also the reason why they ask this is because, see, first of all, you are having a layout, a design which is Excel compliant. Tomorrow, if you leave the company and go, and if somebody has to analyze the design, he or she should be having some information to cross probe between your schematic and layout. And say for that matter, you're busy with some work, and or you're on a holiday, and if your designer wants to debug, or if there is any other colleague of yours who wants to jump in and try to debug the design or make some edits to it, and if at all you're having if you don't have Excel connectivity in your design, it becomes very difficult for that person, be it the designer or the layout guy, to debug and try and see. And even for the designers, right? From the schematic point of view, it looks different, but from the layout point of view, if they have to cross probe and check the connections, for example, say for example, if there is a newbie who is working, okay, and he or she has not taken care of the metal widths, or probably in his simulation results they are getting incorrect results, then they would want to check in the layout what is going wrong. And why is that I am getting incorrect results? Or why is that the resistance is too much or parasitics are too high? What is there in the layout which is giving me incorrect results? So in cases like these, when you're not around, or if they want to debug together, it becomes very, very helpful when you cross probe between schematic and layout. You can check what is the quality of connection being done over there. Are the devices exactly the same? Is the connectivity the same? All those things, it really helps in debugging and rectifying lots of things. Okay, so that's about your check against source.